can you turn the lesson over to the blank back page? I think you do have a back page that's blank. Yeah. You may want to write this down. I did say we've been doing it orally. I said eventually we're going to make a little list. Here are the steps for solving circuits. The first thing that you're going to do is label, and I'll put it in quotes, downhill. Remember, that's from positive to negative. Why do I do that? Now, eventually you'll probably stop doing that because you'll get in the habit of always just moving your eyes downhill. But I like to write something down, I feel better. Okay? Next thing we're trying to do is we want to find I total. Total current, I'll write it that way. Total current. Because if I can find that, it's going to fall apart. Really, then look for amps is really what I'm doing. And what do I mean by total current? I mean total current, and you can put brackets if you want, leaving the battery chairlift. That's what we're looking for. If you get that, trust me, the question's going to fall apart. I can sometimes, they'll give it to me, sometimes it's obvious, sometimes I may see, oh, they told me the two branches, how much current is each of those. If I backtrack, I just add them together, that's the total current must be flowing in using Kirchhoff's laws. 3. Do I know two things? Question mark. Look for any resistor that has two things, so I'm going to know 2 and a 4. And then as soon as you find something, especially if it's a voltage or a current, repeat step 2. Do you know total current now? Which equations are we using here? V equals I times R, and power equals V times I. Ohm's law and Joule's law. Fourth thing, ski. Looking at voltages. Each path must be the same voltage loss as the battery. You get a gain from the battery, you have to lose that many volts. Oh, and there was that shortcut, Nate. Sometimes you might even be able to just say, oh, we split up, and then we met up. Each of those voltage drops must be the same magnitude. If that doesn't work, step 5, rewrite the circuit into its simplest form. And then we can go let me fix this a little bit here. V total, I think I have a subscript option. Equals I total R total. By the way, here, Mitra, usually I'm finding total current, so even though I wrote total voltage equals total current times total resistance, it's almost always going to be I total equals V total over R total. I get you through everything. Those are the 5 procedures. That's typically, if I do it in that order, that gives me a systematic approach. And if I'm not sure what to do now, if I get stuck, go to the next step. Y'all got that okay? Let's go to the beginning of the lesson then. This is called mixed resistor circuits. Hey, we're going to have parallel and series in the same circuit. So to solve these, make sure you identify what are the series and parallel. I would run through Kirchhoff's laws first, but if that doesn't work, simplify the circuit to find the total equivalent resistance, and then we're going to use I total equals V total over R total, and V total is almost always going to be the battery. Right, Nate, who's not looking at his phone or anything silly? You're not that important right now. Work can wait. It can. So, in this top circuit here, can you tell me, you know what, let's call this R1, R2, and R3. Can you tell me two resistors that are in parallel? R2 and R3? I could combine those. I could combine those as 1 over R2 plus 1 over R3 reciprocal. And then I would have something that looks like this. I would still have R1, but now I would have, oh, you know my abbreviation for parallel? 2 lines. Remember we did that for parallel and perpendicular? What can you tell me about R1 and R parallel? Those two are in series, and I could just add them together, and now I've got it as one resistor. That's going to be what we're going to start to practice, Sarah. These 3 are in series. I could add them together as one. Then, once I added them together, these would be in parallel, not these 3 and this one, this total combined and this one. You know what? We really just need to dive into some of these. You can mix and match these diagrams all you want, but until you dive on in, here we go. Example 2. Example 2. Find all the voltages and currents, draw a summary diagram. We're going to label every resistor with a voltage and with a current. And I guess we could then also label it with power, because power is voltage times current. And so a lot of these questions you might see, hey, if these are light bulbs, what's the brightest bulb? My mom said, no, Caleb, something different. Okay. Well, first thing I would do is I would label downhill. Then I would try and find total current, because if I can find total current, this question falls apart. I don't see amps anywhere. I would look for 2 things. I don't see 2 things anywhere, so I've rejected all that already. I would try skiing. Now, here I start with 20 volts. How many volts do I lose here? Don't know. How many volts do I lose here? Don't know. That didn't help. I could also ski the outer path, and I get the same issue. So my only strategy is going to be to rewrite this. Eric, I want to be as organized as possible, but I also want to be as lazy as possible. Okay? What can I do here? Okay. So I'm going to say right next to here, so that I'm doing the work roughly on the same area of the circuit, I'm going to write 1 over R parallel is 1 over 10 plus 1 over 15. Kevin and Mitra and whoever else was away last day, I said to do these, it's best to use your reciprocal button, and you all have one, and this is why it's so handy. So 10 reciprocal button plus 15 reciprocal button equals reciprocal button, and that 10 and that 15 are the same as what? If I was marking this question, I probably would have assigned 1 mark if I saw somewhere written R parallel 6. Now I'm going to start to re-sketch this. So this is a 20 volt, a 4 ohm, What can I replace that 10 and 15 splitting up as? Okay. I could redraw this one more time, but I don't think I need to, because now, what's the total voltage in this circuit? I know that. That's the battery. What is the total voltage we have to use up? What's the total resistance of this circuit? Because those two are in series, and I'll be fine if once you get to a few series resistors in a row, Sarah, you just add them up without even showing the work. It's 6 plus 4, it's 10. And now I can find I total. It's V total over R total. Could you do it in your head, Caleb? That would be wonderful if you could. That's total current. This question's going to fall apart. How many amps are leaving the battery? Let's label that. And let's start to follow it. Oh, how many amps in this 4 ohm resistor? Knock, knock. I know two things. How many volts do I lose in this 4 ohm resistor? In your head, please. 8, right? I times R. Oh, now I can ski. Look, 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 look. How many volts must I lose in the 10? How many volts am I starting with? 20. What do I lose here? 8. Leaving. What must I lose here to get to the bottom? Knock, knock. I know two things. How many amps there? I think I can actually do it in my head because it's going to be 12 divided by 10. 1.2. How many amps should be in the other one then? Should be 0.8. Now the other thing I could say is this also has to be a 12 volt loss because we're splitting up and meeting up. If you go 12 divided by 15, do you get 0.8? That would certainly be nice if we got a confirmation that we were right in two different ways. Did you get that, Kyle, as well? If these are light bulbs, which one is the brightest? Find out really quickly on your calculator or in your head. The top resistor, the middle resistor, or the left-hand resistor? Sorry, right-hand resistor. Yeah, it's on the right for you. Which one's the brightest bulb? How many watts is that light bulb, the top one? How do you figure it out? No. P equals I times R, V times I. So it's going to be 8 times 2. Top one's 16 watts. The middle one is 12 times 1.2. Ooh, what's that? Is that more than 16? What do you get? 14. And the right-hand one is 12 times 0.8. Okay, you know what? The top bulb is the brightest bulb. So you'll notice I didn't bother redrawing this one. Once I had it to this stage, I could have redrawn it one more time as a 20 and a 10, but usually by this time I can say, hey, I can get R total on a piece of paper, and I total is V total over R total. Example 6 says find all voltages and currents by drawing a summary diagram. So let's say example 6, example 3. Label downhill. I don't see amps anywhere. You're starting to see why amps, if you see amps, I kind of smile because it just gives you so much more information to work with, but okay. I don't see volts anywhere. In fact, I don't see two things anywhere on any resistor. Skiing is not going to help. I think I'm going to have to rewrite this. Is R parallel going to be, don't write this down, is 1 over R parallel going to be 1 over 5 plus 1 over 12 plus 1 over 6 plus 1 over 2? Is that correct? No. Because these three are not in parallel with each other. What can you tell me about these three? Okay. So if I were to, we're going to do our sketch. 30 volt, 4 ohm. I have a 5 ohm there. What's that right-hand side? 6 ohm. 6 ohm, Mr. Dewick. I was thinking last one we just did. What would that right-hand branch actually be with the 12 and the 6 and the 2? Can we say 20 or not? Is it not 20? 12 plus 6 plus 2? Did I say 7? Oh, Caleb. Do you even listen to him? Wow! I'm impressed. You're nicer than me. Have I mentioned about light bulbs and the brightest? Yeah, okay. So, it seems to me that step 1 is like that. Which 2 resistors are in parallel? The 20 and the 5. Yes? Eric, I said to you at the beginning, I want to be organized but lazy. So here's what I would show for work. 1 over R parallel equals 1 over 5 plus 1 over 20. What is R parallel? So 5 reciprocal plus 20 reciprocal equals reciprocal. What do you get? Even? I don't want to redraw this. Look up, look up, look up, look up, look up. This is what I would do, and I'm fine if you do this. Scribble, 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 scribble. What did you tell me those 2 are the same as? Is that right? Is that okay, Kieran? That's what I think. I'm okay if you do that. I don't need to redraw the whole thing. I'll scribble out the mathematically useless parts. I'll just shade over them quickly with my pencil. Because this drawing, what's R total? I heard it here somewhere. 10. What's V total? What's I total? How would I calculate it? V over R. 30 over 10. So this one is 3 amps. Ooh. Let's label that right here. That's what's leaving the battery. By the way, if this battery had 90 amp hours of charge, how long can it power this circuit if you're bleeding 3 amps? 30 hours. That's why amp hours as a measurement is really nice. And this is why you need to know if you're actually wiring something, how many amps is it going to draw? So 90 amp hours divided by 3 amps, it'll run for 30 hours. Come back. There we go. You are far more patient than me. I'd be pulling a Charles Barkley on him yesterday. Okay. Yeah, well, you didn't hear me say that, but okay. Now, did I just add something to my original diagram, Sarah, that 3 amps? What else? Now let's use that as much as we can. Sarah, how many amps are going through this 6? I know 2 things, so let's flog that to death. Is it 18 volts? Yes? Oh, because now I can ski this run here because there's only one more resistor, one more hill that I don't know. I start with 30 volts. I lose 18 volts. How many volts must I lose in this 5 ohm resistor? I know 2 things. How many amps are going down that middle path? Can't be 3. That's impossible. I have 3 amps in total, and some has to go this way, and some has to go this way. 3 is a bad answer. How many amps are going? How can I figure it out? So what is it? 2.4? How'd you figure that out? Oh, you mean you use this same equation here, but instead of using total and total, it works for each individual? Oh, good, good. So what was it, 2.4 amps? By that notion, then, Lyndon, how many amps are going through the 12? Hey, I know two things. Oh, how many amps are going through the 6? I know two things. How many amps are going through the 2? So I don't need to go further back to my sketch. I can do the rest of this all on here. How many volts am I losing in that 12 ohm resistor? Whatever 12 times 0.6 is, which is? By the way, some of my kids, the habit that they develop as part of their labeling downhill, on each question or at the top of each page, they write V equals IR and P equals VI, the same way you used to write SOHCAHTOA when you were doing trig. It's just kind of a handy, make sure I don't make a dumb mistake. Sorry, what was the top? A 7.2? And 3.6 volts? Yes? And then I can get the 1.2 by going I times R, or I could say this is 12 volts. These three have to add to 12 volts. I could go 12 minus 7.2 minus 3.6, and I also get 1.2. And the fact that I get the same answer in several different ways, I must be right. All I can do is add more junctions and stuff. Maybe I can make it so tough that you actually need to draw a second mathematical equivalent instead of just one. Here's a great example of using principles of physics right to explain question. What happens to the total current in this circuit when the switch is closed? So this also is why we have to wire ammeters in series, because that way the whole current is going through there. If I had wired the ammeter like this, some current would go through here and I wouldn't know how much. The ammeter, it acts like a gate. Current has to go through the ammeter. So I would have to, if I wanted to get total current, I could put the ammeter anywhere along here and that would give me the total current. But if I put the ammeter there, that would not tell me the total current because some amps would be going this way. Okay. Increase, decrease, or no change? Increase? You know what? Let's solve this. Now, I will on a test give you a question like this with no numbers. Can always make up reasonable numbers and crunch the answer. I'm going to make a prediction first. Before we actually solve this, I opened class. I didn't record this, but we looked at the homework from last day. When you close this, you're adding a resistor in series. When you add a resistor in series, what happens to I total? What happens to R total? When you add a resistor, hang on, I said that backwards. You're adding a resistor in parallel. Do it, you botched that. When you add a resistor in parallel, what happens to the total overall resistance? Does it get bigger or smaller? So I see half of you going like this, and I see half of you doing this. Which one? It gets smaller because you've opened up another ski run. The overall resistance got easier when you added it in parallel. So R total decreased. And since I total equals V total over R total, when we close the switch, what's going to happen to the total current? If R total got smaller and the battery hasn't changed, linear. You're right. Increases. You've lowered your overall resistance. And here's my metaphor. Hey, we just opened another ski run. We can fit more skiers on the hill because skiers are current. We've lowered the overall resistance by adding a resistor in parallel. So the answer is going to be now, if we wanted to prove it with numbers, we could as well. You would combine these into one resistor. Then you would combine it with that. You could actually find, first of all, you would find the current right now. Right now, these two are in series. So, while the switch is open, what's R total? In your head. While the switch is open, what's our total? Nate, 25. So what's I total right now? It's going to be 100 divided by 25. While the switch is open, it's 4 amps. When we close the switch, We're going to see if we can do this all on our calculator. Get your calculator out. When the switch closes, now I have these two in parallel. So I guess that would be the same as 1 divided by 5 plus 1 divided by 10. Or you can use your reciprocal button. I prefer the reciprocal button. And then reciprocal after that. Oh, by the way, what's the smallest resistor out of these two? I told you the parallel result is always smaller than your smallest. It always will be. You can play around with the numbers, but it always will be. So this is the same as a 3.333. Now that would be in series with the 20, so our total would be that number plus 20. The new R total is 23.3 repeating. What's the new I total? 100 divided by that. 4.3. 4.289. Let's go 4.3. Okay? If they wanted a proof, there's a proof, although I would probably accept that because I would say I'm okay if you have learned that if you add a resistor in parallel, it lowers overall resistance, which raises overall current. By the way, the fact that the current went up, so here's what would happen. When you closed this switch, this bulb would get brighter. This one would get dimmer because now it's splitting the current between two bulbs. Yeah.
But if you added a resistor
in series, that increases overall resistance. Absolutely, that does. Yeah. What's your homework? Short lesson. Number 1. Number 2. 3 is good. Number 4 just wants you to find the total resistance. They didn't tell you a direction. If you don't like not having a downhill, you can make downhill to the right. You'll get the same answer either way. It just wants you to rewrite that. 5 is good. Ooh, 6 has asked me to find the battery. Ooh, I see current. I bet you this question's easier than I think. 7 is a cool one. 7 is on the upper threshold of what I would feel comfortable asking. The key is they have told you that 3 amps is flowing through this 6 ohm resistor. That's the key that breaks the rest of this wide open. I'll let you try that. 8 is good. We did that, yes? Before I turn you loose,